Ladies and gentlemen, this is the 3.3 instructional video on literal equations. Your teaching point for today is that you will learn how to solve an equation for a given variable. Your success criteria, as always, will be to show all your work. All right, ladies and gentlemen, take a moment to jot down this equation. B times H equals A. You may recognize this as the formula for the area of a rectangle. Base times height equals A. So in this particular problem, I want to solve the equation for B. So what that means is I need to get B by itself. Now you'll notice in this formula, I don't have any coefficients or numbers. So sometimes when I'm solving literal equations, that means that I won't be able to do a lot of simplification in the end. So because a moment ago I said the formula is B times H equals A, to get B by itself, I need to do the opposite of times H, which means I'll have to divide both sides by H. So when I do that, I'll get B by itself, because my H's cancel, and that will equal A divided by H. So a reason a mathematician might use the literal equations to speed up their job or their workflow is perhaps a mathematician is using, has several areas, and they know the height of the rectangle, but they need to calculate the base. Well, instead of using the original equation and doing the divide by H step when you know the value of H, in this particular case, the mathematician could take the area divided by the height to get the base value, or the length of the base. So literal equations can help speed up the workflow for a mathematician. Okay, ladies and gentlemen, here's the second example. So go ahead and jot in your notebook 3x minus 4y equals negative 12. In this particular case, you can see we want to get x by itself. So to do that, we need to get rid of, subtract 4y on both sides. So I will add 4y. Okay, when I do that, I'll get 3x equals 4y minus 12. To get x by itself, I divide everything by 3. This should look familiar from when we did some work with solving systems of equations using substitution. I will get x equals 4/3 y, or you might write 1 1/3 minus 4. So you can see what I've done here is I've isolated x, so x is by itself. Okay, ladies and gentlemen, here's your third example. So take a moment to jot down 2x squared plus y equals 12 into your notebook. You can see in this example again we are solving for x, so I'll first need to subtract y on both sides. And I will get 2x squared equals negative y plus 12. I need to get x squared alone before I can get x by itself, so I'll have to get rid of times 2. So I'm going to divide both sides by 2. Now, anything that you can simplify, go ahead and do so. So I'm going to rewrite this first term as negative 1/2 y. And then I know 12 divided by 2 is 6, so I am going to put plus 6. All right, so my last step, now that I have x squared equals negative 1/2 y plus b, is to get this squared, this exponent. I'll have to get rid of that. So if you remember back to when we learned about the Pythagorean theorem, to get rid of the squared, I need to take the square root. So I will go ahead and take the square root of both sides. So now I'll have x equals the square root of negative 1/2 y plus 6. And I want to point out that all of that is underneath the square root. So, ladies and gentlemen, sometimes when you're working with literal equations, you don't have a lot of things to simplify. Simplify anything you can. Sometimes the final answer doesn't always look pretty, like in this particular case. There is a big equation or formula there with a lot of math symbols involved. All right, ladies and gentlemen, it's your turn. Jot down both of these equations. Solve both of the equations for x. And I do want to caution you when you're doing your homework for tonight, read the directions, because not every single example will have you solve the equation for the letter x. So you might be solving for different variables. All right, good luck.